Welcome to Shaping Industry Today with Schneider Electric, where we explore the latest innovations shaping our industries. Today, we are coming to you from the Schneider Electric studio at Hannover Messe, the world's leading industrial trade fair. I am Marc Lafont, Vice President for Innovation and Upstream Marketing in our Schneider Electric Industrial Automation Business Unit, and I'm glad to introduce this session on the flexible and autonomous plant, a new era of manufacturing. Today, I'm talking with two strategic partners of Schneider Electric, Microsoft and Capgemini, on the transformative impact of cutting-edge technologies within industrial automation. Let's dive right in. So joining me today, we have Thomas Pfenning, Corporate Vice President of Azure Edge and Platform at Microsoft, and Nicolas Rousseau, Executive Vice President and Chief Digital Engineering and Manufacturing Officer at Capgemini. Welcome to both of you, and thanks a lot for being with us today. So I'd suggest we start by exploring what is this new era of manufacturing, and I'd like to start with some observations from a Schneider Electric perspective. We've been over the past years through the shift and a journey for our manufacturers with plants being more and more connected, open, driven by data for decision making, and powered by software-defined automation. If I spend a little bit of time on those software-defined automation concept, at the core of the concept, this is about, I would say, the decoupling of automation and control system from the hardware physical layer. We've been leading such a trend with our flagship offer, EcoStruxure Automation Expert, and we have now many testimonies from customers highlighting the flexibility, the efficiency, including sustainability and resiliency that such a concepts are bringing. However, now there's plenty of market pressure that the manufacturing industry is seeing, and we need to go further. I'd like to mention some of those market pressure that manufacturers are seeing, and I'll see four of them, I think. First of all, their own customers are asking for more and more customized products, faster deliveries, still with the right sustainability. So that's the first pressure. Second pressure, I would say, is about the regulations. The manufacturers need to comply with stricter and stricter regulations, for example, on traceability or on sustainability again, or cyber security. The third one is related to their need to face different crises. Over the past years, they had to face many crises, pandemia, electronic supply chain tension, geopolitics, and they might expect more and more to come, and they need to be resilient in front of the future crisis. And last but not least, also they see a very rapid evolution and I would say adoption of new technologies, which is a good thing, but it's also creating a workforce skill gap, which is creating pressure for them. So that's why the manufacturing industry wants to go beyond, and they are also forcing their manufacturing plants to be more and more flexible, more and more autonomous, and creating more and more collaboration between the process, the machines, and the human at the core of it. And that's where innovation will take place. So Thomas, can you give us also some perspective how you see this new era of manufacturing?
Yeah, good morning. Yeah, thank you, Marc. I have to agree with you. We are definitely in an area of transformation, particularly with industrial manufacturing and software-defined automation. But I think most prominently with the upcoming era of AI. And I believe the future of manufacturing is data-driven and AI-assisted, particularly by co-pilots and AI agents, enabling customers to collect and ingest their data across the different domains of IT, OT, and Edge into a scalable and feature-rich data platform, something like Microsoft Fabric, which has rich APIs to query and reason over the data in natural language. That's the path of the future. On the developer side, the software development tools that in the industrial space have also been quite cumbersome will benefit from having AI-assisted co-pilots, and GitHub with Copilot and Visual Studio with Copilot. That will help in cutting down the time for modernizing and accelerating the development. When we look in some of the details, the data platform is allowing you to basically bring all the data from the machine floor, the physical world, the operational data, supply chain, and IT world together in a single data lake. And you will be able to draw conclusions from that data using very simple language that basically gives you everything from the factory floor to the boardroom. On the co-pilot side, I know Schneider is heavily developed into the IEC 61449 tools, and these artifacts are complicated. And with sort of our joint development there, we can cut down the time to create them and dramatically reduce human errors. And so ultimately we see sort of like data-driven manufacturing, and with all the data being uploaded into a single fabric, allowing rich analysis and improved flexibility and updating of the application code by AI-assisted tools.
Okay, thank you. Nicolas, can you weigh in, please?
Yeah, sure. And I would complement a little bit what was just mentioned about really the data approach and what are those third technologies that are required somehow to come and feed those data lakes and how we kind of come there, I believe are quite complementary between our different approaches. So if you come back about the future of manufacturing and the flex and autonomous plant that we were mentioning, I think for me, and again, it's just stating the obvious, but everything will be next-gen technologies driven. Okay, so we discussed about AI, but obviously everything related to software-driven edge computing, advanced connectivity, which we tend to forget from time to time because you need to bring the data somewhere, are really those technologies that's going to drive the change. But what's important as well from our perspective, it's only the technology, not for the tech, okay, but also the technology for a purpose, right? And if we talk about really the manufacturing space, there are three main trends, just to echo yours, that we are seeing that are important. First, it's all about resilience and agility. Okay, so how do we go to face those crises that you've been mentioning? How do we enable this reconfigurable plant approach using simulation, using any kind of technology that is enabling this for the resilience? That's point number one. Second, which was stated and on which I will not elaborate a lot about, is the intelligence-driven efficiency. So we're obviously based on data, but really as well, and I guess we're going to discuss that a bit later, is where do you compute those data as well, just to be relevant in really the pace of the manufacturing, okay, where it's real-time operation. But I suspect we're going to touch on that later on. Last but not least, you were talking about sustainability. I'm tightening that as well with smart operations. As well, how do you really, from those edge-native, edge-to-cloud architecture, come to something that is relevant for the human, for the operator on the ground, is, I believe, what is at stake to go really beyond the technologies. So for us, and I would really conclude on that, it's, again, not the tech for the tech, it's the tech for a purpose and for an operator on the ground at the end to really make that happen.
Okay. I think we've set the stage. So I suggest we dig a little bit deeper now. And what I'd like to start to discuss, as you pointed actually, Nicolas, is about how we are going to transform the manufacturing operations and how we are going to make the plants of the future more flexible and more autonomous. And behind it, what are the architectural transformations which are going to happen? I think over the past years, we talked a lot about the industrial Internet of Things, where, to make it simple, we have monolithic systems capturing a lot of data on the shop floor and pushing those data outside of the boundaries of the manufacturing plants, very often in a cloud infrastructure where many great algorithm and computing capabilities will help to bring optimization of the process, optimization of the asset lifecycle, etc. But now we are seeing a shift to actually distributing this IT intelligence down to the plant and across the machines and the manufacturing lines. And actually, we see two main benefits for that. The first benefit is related to the flexibility that it gives for a manufacturer to run his workloads, his control and compute intelligent workloads wherever he wants, close to the place where the data are produced or where some of the data are consolidated. And it gives value actually in terms of security and in terms of sustainability, because the manufacturers don't have to push all their data up to the cloud. They can really select what they want to push and optimize the way they are doing it. But how we are doing that? There's two things, key things actually we are doing. First of all, we are really transforming our devices sitting on the plant floor, giving them the opportunity to run those kind of IT compute workloads. But we are also rebuilding our industrial communication networks, because we want to have to make sure that we have an end-to-end IT to OT converged network. Basically, it means a network across which any device, any application, any software tools can communicate together seamlessly, like if they were on a flat network, but actually with the right cybersecurity settings. So that's the first benefit: flexibility, giving I would say security and sustainability. But the second benefit is, of course, to be able to bring intelligence down to the manufacturing lines, down to the machines, down to the devices, to make those assets, I would say, smarter and capable of making autonomous decision, or at least assisting the human on the ground floor to make those decisions. And the way we do it, actually, in Schneider is to reinforce this level of autonomy, is to couple control workload, virtual PLC, together with those edge computing capabilities. If I take an example, imagine a machine running its control sequence and being able to integrate actually visual inspection, yield optimization, predictive maintenance in real time, so to make sure that the machine is making the right decision in real time or making the right recommendations. On top of that, also, we want to bring this autonomous level of orchestration. So basically, the idea is to try to minimize the cognitive load or the manual interventions for the people on the plant to think about how to distribute all those applications, how to redeploy them when there is a problem, etc. And I think we are quite unique here in Hannover to showcase the combination of virtual PLC together with edge computing workloads orchestrated in a real-time network, and that's something we are showcasing here in Hannover. So, Thomas, can you also share on your side your perspective about this distributed intelligence and this new type of intelligent edge?
Yeah, sure. At Microsoft, we've been working over the last couple of years to bring the power of and the well-tested and scale-proven services that we're running in Azure to run our public cloud and extend those out to the edge sites, which allows you to basically leverage the same tools, skill set in employees to develop and manage the applications that run on the edge sites in a similar way like what you're doing in the cloud. The benefit of that is that you get the same security, role-based access control, monitoring, logging, deployment methods, templates, the same controls via CLIs and UIs that run in the cloud can be extended to all the tools that now run on the edge. This is done in a way that you can survive disconnects on the edge. It's a secure channel up, and security, as you mentioned, cybersecurity is a big part of it. We have a lot of experience with security, and so being able to not having to reinvent that but leverage it is a big benefit. And from a tools perspective, we allow you to have applications that span cloud parts where you would basically upload all your data. So you can bring the OT and IT data together, like I mentioned before, while you have like autonomous control on a distributed system, HA clusters running on the edge sites. And they will allow you to basically host your local AI applications, local control applications, and doing sort of like controlling whatever you need on your assets on-prem. Ultimately, the benefit of this is you get scale-proven technology common skill set for the employees, and you have Microsoft being able to provide, starting from bare metal, greenfield, easy deployment of like the components on-prem. We can also pick up like existing equipment, either at the level of Kubernetes, which is like the main technology that drives our Arc connection. We call this technology Arc. And those can be either Microsoft-provided clusters, or it could be third-party clusters that get Arc-enabled, at which point all these resources you have on-prem show up as resources in Azure and can be managed exactly the same way.
Okay, thanks, Thomas. That's great. So Nicolas, so we've been collaborating actually a lot between Schneider and Capgemini on building that intelligent edge that I was talking about. And actually here in Hannover, we are even showcasing it on top of private 5G infrastructure. Exactly. So, and I think why we are doing that is really to show even more flexibility and more efficiency from those transformative architectures. So can you please elaborate a little bit more on that?
Yes, sure. And if you allow me just to rebound on what the two of you mentioned before. I think the continuum you were mentioning from the device to the edge to the cloud is, for me, the absolute pivot that's going to happen. We're talking a lot about the edge itself, but I think really making the conscious decision of where do you put the compute? Is it on the device? Is it at the edge or the cloud? Is really the pivotal aspect of the new architectures that are about to be created. So just really to echo what you were saying, I think is very important. Coming back to your question about really the intelligent edge, I would like to take really those two between the 5G and the edge somehow. So we're indeed, as you were mentioning, demonstrating all this in our respective booths. But 5G had for 5-6 years already, had really the promise of the ultra-low latency, the high reliability, the massive connectivity, but was a little bit missing, I think, the use cases. And what we found at Capgemini really interesting was really combining it with the edge approach, which is really enabling those promises of the low latency to where you compute it. Because what's the point of somehow saving a couple of milliseconds, okay, if you're losing them, sending them to the cloud? So that's this whole combination, which we believe is relevant about really this high-end connectivity and the edge as well, okay, like you're mentioning, okay, where we're partnering to really create those new use cases that are making sense from not only a technological perspective, but also from a business perspective and operator perspective, and really enabling all the promises that Microsoft was really alluding to. But I think this is really a pivotal piece. The second piece, which is what you were mentioning about the 5G private networks, right? For me, it's all about as well, it's all about security. It's also mastering the end-to-end piece to coming to something that, from a manufacturing perspective, you're totally mastering. Not really, we could discuss and argue about the private cloud and the public cloud for ages, I believe. But I think really this private 5G also enables this full end-to-end, let's say, comprehensive view, also from the plant perspective, which I believe is pivotal. And the last thing I wanted to rely on, or to rebound on, was the orchestration. Okay, because we can talk a lot about all those magnificent services that Edge AI would create, but if you don't get it properly orchestrated at the right edge node level, then all the things will be seen here. Okay, so how do you make sure, and also because already within a Schneider environment, okay, so how do you make sure that everything's connected? But if you come to a plant manager orchestrating many, many different things, many different data, from my perspective, it's not only putting everything into a data lake, okay, and hoping that somehow by shaking it, somehow things will come out, but it's also how do you orchestrate it ahead of it so that it does make sense.
Thank you. No, that's great. We are working on those things together. Okay, so we've discussed a certain number of technologies, new technologies, and I will say transformation of the architectures, which will make the plants of the future more flexible and more autonomous. I'd like now to spend a little bit of time on what will be the impact on engineering. Because to unlock the full potential of such a plant of the future that we've been describing, we probably need to rethink the way we are going to engineer them. I'd like to start, I mentioned earlier the software-defined automation concept. And I talked about the decoupling between the hardware physical layer and the software layer. That's already a first important step because we are making the solution vendor agnostic, removing the constraints so the manufacturers can build the performance of the plant without wondering what will be the monolithic constraints coming from some physical layer. And the way we are doing it with EcoStruxure Automation Expert, with a new paradigm of building the applications asset-based, event-driven, is already demonstrating a lot of engineering efficiency. But okay, the future plans that we've been describing, I think we can see that they are mixing a lot of OT, operational technologies, with a lot of those new IT technologies. We talked about AI, edge computing, orchestration, 5G. So we need to make sure that's something very easy to engineer in the future. And I'd like here maybe to mention two examples of technologies that we believe will be important on our side. First of all is to rely on what we call the DevOps type of technologies coming from the IT world for helping, I would say, engineers to collaborate together, have streamlined workflows, being able to accelerate their development. Imagine engineering platforms where the engineers can actually co-engineer together, review their work wherever they are based, whatever is their experience, and really accelerate and be able to work all together. So that's one technology example which is important, we believe, in terms of adoption. The second one, obviously, generative AI. It's been revolutionizing many industries, and we see it for sure impacting a lot our industrial automation domain. And that will be a great tool to close the skill gap that we might create by introducing a lot of new technologies in the plants of the future. So, Thomas, we have many collaborations between Microsoft and Schneider Electric, but I'd like maybe also to you to elaborate a bit more specifically on what we are doing in combining your capabilities around generative AI, copilots type of tools, and of course our automation expert type of software tools.
Yeah. So, Mark, as I mentioned earlier, the challenge. Like I liked your comment, sort of like on the shop floor, the orchestration is key. And as it turns out, in the real world, in the physical world, orchestration is actually hard. And the tools that we have with the Schneider Automation Expert require certain artifacts to drive these orchestration workflows. Defining and designing those requires highly skilled people. And what we have been collaborating on is leveraging our generative AI tools and writing a specific co-pilot that helps us the creation of both the artifacts required for the automation expert, as well as then generating help information and allowing sort of like users to ask questions about these workflows. So it all comes together, the initial deployment. Then in the operational phase, you can basically deploy the AI to ask questions about the data, failure cases, and you basically ultimately, with your operational data flows up to the cloud, you have another co-pilot where you can basically look at the data and ask about energy efficiency, minimizing downtime, optimizing productivity. So we have quite a set of comprehensive applications for these modern technologies, and I believe sort of the collaboration with Schneider is trying to basically roll this out across a portfolio of product lines. What that means is we're bringing together really sort of like the Schneider skill set of like decades of industrial knowledge and the Microsoft like tooling for enabling generative AI to be applied to those. So this has a potential of kind of being a little revolution on the shop floor of bringing sort of like an end-to-end solution that is effective, flexible, easy to change, and gives a lot of insight between OT and IT that has not existed before.
Yeah, actually, it's thank you. It's really super exciting what we are building together, and actually we are quite proud to showcase that on both your Microsoft booth and as well on our Schneider Electric booth.
Don't miss it.
So, okay, you talked actually, both of you talked a lot about collaboration. And actually, I'd like to close the discussion on that topic because it's obviously very important. And I'd like first to share some Schneider Electric perspective. And I'd like to go through 3 angles that we believe are important for our manufacturers in the fact that groups like ours are working together. The first one is about co-innovation, open innovation, I should say. Innovation is at our DNA. In Schneider, we are always trying to leverage new technologies, and we are trying to work a lot with technology suppliers, startups, universities, research labs, and of course, strategic partners like you. Why? Because it's actually helping us to be much bolder and much faster in bringing innovation and bringing values to the manufacturing industry. So that's the first angle. But the second angle is about this combination of OT and IT. I mean, in Schneider, we've been, and we are a domain expert in automation for decades, of course. And we saw in this new era of manufacturing the importance of IT. And so for us, the importance to be able to learn and work with groups like yours coming from the IT world. The last angle that is important, we believe, is about interoperability. Because in the end, our manufacturers, they want all the products and the software tools, etc., to be able to work together seamlessly. We've been mentioning a certain number of technologies, and that's really creating value for them. It's breaking this vendor lock-in that I mentioned earlier, and it gives really the flexibility for the manufacturers to choose whoever they want to work with, or even across the life cycle of the plant to be able to bring in new suppliers. We've got many examples on which we are building some interoperability standards. unifiedautomation.org. I talked about software-defined automation components, which needs to be vendor agnostic and interoperable. We are also working on the alignment to Margot in terms of intelligent edge architecture and the interoperability between edge devices, edge applications, and orchestration tools, and so on. So, Nicolas, I'd like to hear as well from your view what you think about partnerships, co-innovations, or interoperability.
Yeah, thanks, Mark. That's quite a broad topic. I think we could spend more than the remaining minutes that we have together. But maybe if I would pick up some of those topics that you've been mentioning and that Thomas mentioned as well. I think first on the innovation piece, you were mentioning also the challenge for the workforce to embrace the new technologies. Take Kubernetes that you were mentioning, as how do you push Kubernetes to the shop floor is a real challenge. And somehow back to the innovation, because the pace of innovation is so fast that I believe that there's no company on earth almost able to innovate on its own. Okay, so it could be on some segments, okay, but really if you look the complexity of the shop floor, coming with one size fits all kind of a solution is not possible. So this is where I believe the combination of those trends that we have as corporations is really level setting, I'd say, what is feasible. Second, on the interoperability we've been mentioning before, at the end of the day, and this was what I was mentioning before, that everything that we're doing on technological side had to fit the purpose. And when we're discussing with our customers on the ground about their effective challenges or the trade-off that they have to do between investing in technological, let's say, disruptions or building up an add-on, okay, it's always a trade-off they need to make. So somehow this interoperability promise that we're bringing, okay, the abstraction layer between the hardware and the software that we're bringing, is for me a massive opportunity as well to create this interoperability and enable the business value out of that. And really, I think to come to your point, and that we've been mentioning, the proof in the pudding is also to really see, okay, what's going on. And therefore, those demonstrations that we're respectively making, I think is a tangible proof that all the premises that we're doing through the Margo initiative, okay, are not theoretical or not really things from very interesting engineers or doctors really thinking about what should be the next innovation coming. It's real. And I guess from our roles, the whole point is make the tech real. And if you achieve that, I believe that at the end of the day, the promise will be held.
Okay. And Thomas, on your side, some perspective about collaboration, partnerships?
Well, for Microsoft, we're mainly a platform company. And so for us, partners is like a crucial ingredient to everything we do. And especially with partners like Schneider, who have been working with us for decades. We're sort of like bringing together sort of like your expertise and some of our new tools and new technology to basically build the foundation of something that brings in a rich ecosystem of industry partners, because any single manufacturing line has multiple technologies. So there's connectivity problems. So we have a broad set of partners that solve that connectivity problem. We got like components that allow you to basically onboard all these devices, harmonize it, contextualize the data. And all of this is driven by the practical experience from partners with Schneider. The other area where we are seeing dramatic uptake of the platform is actually in the area of real-time AI models. So if we have like IT components running on-prem, where do all these models for quality control, predictive maintenance coming from? So all of this together with our partners, is what enables us to be successful in the market. So thank you.
Okay, those are great statements to end with, but I think we are a bit running out of time now, so it's time to wrap up. I just want, as a wrap up, to say that we talked about the new era of manufacturing as a vision, but I think it's not a vision. We are actually shaping it. It's made of making the plants of the future more flexible, more autonomous, more collaborative, on top of those software-defined automation architectures. Of course, it's relying a lot on new technologies, transforming the architecture, transforming the way we are going to engineer those plants of the future. And bottom line, this is about more efficiency for the manufacturers, including more sustainability and more resiliency. But it's not only about technologies, you said it well, it's also about innovating together, collaborating together. So that's why I think let's keep working together. Big thank you to both of you for your time in this panel. And thank you as well to you for watching this session. I hope you enjoyed it. And I hope also you will join for more episodes of Shaping the Industry Today with Schneider Electric. Thank you.